Today we're going to be discussing or demonstrating voltage drop testing on a truck. We are going to be carrying out a voltage drop testing on a vehicle today. We're only going to be dealing with one side of the circuit, and that will be the cranking circuit itself. The same principles apply to the control circuit as well. So demonstrating just one side will show you or illustrate to you how to complete a complete cranking circuit, including control and cranking. Prior to conducting any cranking control circuit testings on a vehicle, the first thing you must do is ensure that you are doing it safely. There's a number of safety precautions that one must complete before conducting any testings. The first thing is you must ensure that your vehicle is secured and chocked, as well as you should ensure that before you do any testing that the vehicle is in neutral and that the engine is disabled so it will not start. During voltage drop testing, there's three primary tools required for testing. The first instrument used will be your remote start switch. Your remote start switch is used to control or activate your solenoids and relays. The second important piece of equipment to use is a voltmeter. A good quality voltmeter is the best thing to use. That determines what the voltage drop is across your circuit. The third and final most important piece of equipment is your ammeter. That measures the total current flow through your circuit at the point you're registering it. Prior to doing any cranking circuit testing on any vehicle, the first thing you must establish and verify you have a good battery system. So the first thing you check is your open circuit voltage on your battery system. So whether you've got one battery or four batteries hooked in series or parallel, you have to ensure that you have the minimum required cranking voltage. It is important to remember that no matter what you're doing electrically on a vehicle, that you have to ensure that you do have good battery voltage, whether it be cranking or charging. Now, prior to beginning any testings, we have to ensure that the engine is disabled and will not start. On this particular engine, we can disconnect the SRS-TRS, and that will cause a reference signal not to be sent to the ECM, allowing the engine not to start. So first thing we do is we'll disconnect that and we'll verify that we actually have a no start but a cranking condition. First thing we'll do is we'll put in line our ammeter so that we can verify what our cranking amperage will be during cranking. In this particular instance, we place it onto the ground strap, because as it is known that no matter what comes out of the battery amperage wise has to go back to the battery amperage wise. So your ammeter can be hooked on your power side or your ground side. Now, being that we're carrying out this testing solo, what we will hook up on here is our remote start button. We will use that to jump from our S terminal on the starter solenoid to our B terminal. Now we will verify again that this is actually in a functioning order. Okay, so it does actually perform its task. Just to get an understanding of what terminals we are discussing about, we've taken the starter motor and we've placed it onto a bench so we can highlight the components we're talking about and the connections. This terminal here is your battery terminal, is your primary power supply. It's generally speaking, it comes directly from the batteries up to the starter motor, and all electrical accessories run off of this port here. This here is our solenoid terminal. It gets a feed wire from our control circuit, from the firewall relay, or directly from the starter button inside the cab of the vehicle. This here is our hold-in winding ground strap. So there'll be a wire that runs from here over to here to our starter motor ground, which will keep our hold-in winding energized during the cranking cycle. There's also another terminal, another wire in here that goes from the solenoid terminal to our motor terminal, which is the pull-in winding. That pull-in winding allows the plunger inside to overcome stall and force it back, causing the action of the starter motor. This here terminal is our M terminal or our motor terminal. It directly feeds into the starter motor itself. Inside the starter motor, it can be either series wound, compound, or shunt wound starter motor. But the ultimate ground is out through the ground strap. During our connections, we will take our, when we have this on vehicle, we will take our jumper button and we will go from our battery positive here to our S terminal there. That allows us to control the supply of current to our hold-in, pull-in windings, allowing us to activate our starter motor. During on-vehicle testing, the ammeter can either be placed around the positive cable or the ground cable to read our current draw. The meter itself, the voltmeter for the voltage drop testing, you take your most positive point, which is your red lead, and you place it onto the battery terminal of the starter motor, and you can turn around and take your ground and apply it to the ground strap of your starter motor. That will tell you what the voltage drop is from your battery terminal to your ground terminal. Main current goes from your battery terminal in through your solenoid, across the contact disc, out back through the starter motor. If you wanted to check the voltage drop across your hold-in winding, you would go from your S terminal or your solenoid terminal to your solenoid ground terminal. And that will measure just the resistance of your hold-in winding. To measure the resistance of a pull-in winding, you would have to go from your S terminal to your M terminal. And that would measure the resistance. You can't do a voltage drop test on your pull-in winding because of the fact that bulk of your current will be coming across your contact disc. Next step will be to take our voltmeter and we will apply it across our starter motor. We will place our positive probe or our power probe closest to the battery source. Our ground will go closest to the ground. So with these in place, we will crank the engine. And we are showing a 9.68 volt drop across the starter motor. And that is determined by, when you place this probe on the positive side, or closest to your battery of a circuit, and place this one on the negative side closer to your battery, the potential difference between the positive probe and the negative probe is what the difference is from the voltage applied here and the voltage being read here. So your positive will read 12 volts and your negative will read 3 volts. So it's saying the potential difference between the two is 9 volts. So therefore you had a 9 volt drop across your circuit. On this particular starter motor, we showed a 9.68 volt drop across the starter motor, which is close to normal specs. But to verify that, you would have to check with the manufacturer and ensure you got the proper specifications.